So welcome everybody to Math4707 Spring 2020, our adventure in online teaching. I hope you all are doing okay and keeping your spirits up. So today I just want to talk about a bit of what's happening in the course for the rest of the semester, and to talk about how we'll try to get through this, and we'll try to be easy on ourselves, and we'll make mistakes, and we'll make more of them because it's online, but hopefully we'll come out of this better in the process. So I've taught this class several times before, as you might have figured out from looking at my syllabus pages, but never online. It was only last spring that the second half of a graduate course that I was teaching, we had to switch over to online, but that was a different story. Smaller class and just slightly different set of challenges. So let's start by talking about the syllabus. And in general, I'm actually happy if, as many as you can, leave your cameras on. Of course, we're being recorded, so if you don't want to be, recorded with camera, you can turn it off. But mute yourselves. I think most of you have muted yourselves, and except when you're speaking, unmute. And you can put questions in the chat as they come up, and I'll try to pay attention to them. And let me start by saying you'll be doing me a big favor if, when you don't see that little recording symbol, that you remind me to record. Oops, looks like my iPad stopped doing its screen broadcast. So let's put it back. So yes, please do remind me to record if you ever see me not recording. I'm terrible about it, remembering. Okay, so what's going on with the syllabus for this class? No, that's not what I wanted. I wanted notability. I hope you looked at the syllabus already. If not, you can look at it after. There's, just a few things on here that I want to point out. For this class, you're supposed to have experience with calculus, even multivariable calculus, linear algebra, things like matrices, and, we'll be occasionally working with things like Taylor series or power series and take a derivative. That sort of stuff will come up here and there, not every day. You're definitely supposed to know about some proof techniques, and there will be questions where I ask you to prove things, and use techniques like mathematical induction and proof by contrapositive, various other stuff like that. If you're looking for resources about proofs, you can ask me, and I can point you to some. I could even put some on the syllabus. As I said, the plan is for all of the lectures to be online like this. And even though the course hours are from 2:30 to 4:25, you don't really need what would that be, like 4 hours roughly of lectures per week for this class. Oh yes, someone is asking in the chat about the GatherTown meeting link. You can find it on the syllabus. Go to my syllabus page, and somewhere where it talks about the GatherTown, you can click and you'll get the link for the GatherTown. And if somebody wants to, they could copy it into the chat. Feel free to do that, but I won't do that now. So the idea will be, this really, in terms of material, this class doesn't have to get to any one particular place. So we're free to just cover whatever material we feel is fun and interesting, and that's our goal, just learn something this semester. And we certainly don't really need more than the usual, 3 50-minute equivalent of lecture per week. So the plan is that I'll shoot for about 40 minutes recorded at the beginning, from 2:30 to about 3:10, but it may, go under or over depending upon what's happening that day. Then I'll turn the recording off. We'll take a 10-minute break just so we can walk around, get something to drink, who knows, something to eat. Come back 10 minutes later. I'll start the recording again. So oftentimes roughly around 3:20. Then that second period will go for another 40 minutes, say, maybe 35 minutes. But the point will be that we get about 75 to 80 minutes of lecture each Monday and on a Wednesday. So that's the rough equivalent of like 3 50-minute classes of lecture. But then we should also have some office hours. And the idea is I'll use that remaining time from 4 o'clock to 4:25. Recording will be off, but it just turns into office hour. And so I'll be here to answer questions. You know, we'll still have my pads so that I can answer questions there if I need to. And we can talk about the material and things that have come up. But I also want to set up some other office hours that are not in those 4 to 4:25 Monday, Wednesday times. So what I'd like to propose is as extra office hour times, Tuesday and Thursday at 9 a.m. And so what I'd like you to do is if you have, you know, strong negative feelings about Tuesday and Thursday at 9 a.m. office hours, if you'll never be able to come to those, and if you feel like you'll never be able to get your questions answered in those extra Monday and Wednesday 4 to 4:25 periods, let me know. But otherwise, I'm going to write this down, proposed office hour slots are Tuesday, Thursday, oops. I guess this would be at the 9:05 to 9:55 a.m. time, okay? And those would be, again, using the same Zoom room. We could think about potential other ways to do it. I don't know that GatherTown thing, we'll have to figure out what are the capabilities of GatherTown, but I have a feeling that it's not going to be adequate for doing the office hour. But if it is, if any of you have experience with it, I've never used it before, then we could do the office hour in the GatherTown link. This brings up another point is I would like to, as it mentions on the syllabus, set up a Discord server as a way to make it easier for you folks to organize study sessions and just find other people who are working on the homework at different times, get together. I think that is a great idea. And if you look on the syllabus, it says, yes, please do work with other people on the homework. The only thing, if you look in the part of the syllabus that talks about homework, exams, and grading, it says, sure, I encourage collaboration, but I just want everybody to understand the solutions, write them up in their own words, and indicate on the homework page for the grader. I probably will not be grading the homeworks, just the exams, but indicate who you collaborated with clearly on the homework page. If the similarities between the way people have written up the solutions are just too close, then the grader is going to become suspicious and say, you know, please try to think it through and write it more in your own words. The idea is to make sure you've learned this stuff. Okay. So the homeworks are every 2 weeks. They're due on Wednesdays. We've got the schedule for when the homeworks are due already in a table that's at the bottom of the syllabus. Okay. And then there's the midterm 1, midterm 2, and the final exam, which are each worth 20% of the course grade. So the homework is 40% of the grade. These exams are 60%. Those are going to be graded by me. They are obviously take home as the homeworks are. We're going to try to hand them in and get them back through the Canvas site. That's going to be the main use of the Canvas site as far as I'm concerned. I haven't been convinced that I should use it for a lot else. In particular, I'm going to try to upload the videos to YouTube, put the links on the syllabus page. I might try to upload them to the Canvas page, I might not. I find that YouTube is actually a little more reliable. So the idea would be that when you have those homeworks that are week-long take-home, you are supposed to be working on those yourself. You're not supposed to consult your fellow students. This is me trying to see what you're capable of doing on your own when I grade it. And so that means You're also not supposed to, go to Chegg or go to any other online human sources. You can read things that have already been posted on the web. I mean, you can try to look up information about the problems and stuff on the web. That's fine. I would appreciate it if you would also tell me when you've used some sources that you found on the web for those take-home exams and the final exam. But please do not consult any humans through the web who haven't already written something for the homework and the final. I'd like to ask now, does anybody have a question about me clarifying that policy for the homework versus the exams? It's a different story in terms of collaboration. Essentially, no collaboration on the exams, plenty of collaboration on the homework. Can I answer any questions for anyone or clarify?
So to be clear, you can use certain online sources or any online source you want for the test as well. You just have to cite them?
You have to cite them, but for example, your online source should not be consulting a live human to solve the problem.
Okay.
It can be a posted source, like sources that were already there on the line, online, the Wikipedia pages, and there's these things like Math Stack Exchange, Math Overflow. They do answer math questions, but don't post the question and ask someone to answer it there for you, please.
Does that mean we're allowed to ask dead humans?
Dead human. If you have a Ouija board, you can consult a dead human. Spiritualists in this class, you're in luck. Other questions? Okay. Let me take another look at the syllabus and see.
I have a question.
Oh, yes.
What sources on the internet would not be allowed? Like
Chegg. Have you ever heard of Chegg?
Yeah.
That one.
So can we use can we look up a similar problem? And
if there exists a similar problem, sure, I guess. Yeah.
I'm scared.
Pre-exists a similar problem. Yes. Pre-existing sources posted on the internet. That's okay. Further clarification? Okay. Yeah, I feel like, yeah, I think everything else you can read on the syllabus. So if you have more questions, after looking at the syllabus after today, just send them to me by email, ask them in lecture. No problem. We've got time. Oh yes, so regarding the Discord server and collaboration and so on, I will take a volunteer to set up the Discord server for this class. I'll bet there are many of you who have used it a lot more than I have. I had an account on a Discord server that somebody else set up. I've never set one up myself, but I don't think it's hard. But anybody who'd like to volunteer to set up the Discord server for this class, yeah, please volunteer. Send me an email. Tell me in the chat, whatever. We should do that as soon as possible so that you can start talking to each other. And I think once it's set up, all I need to do is give you the emails of people in class to invite them. So shouldn't be too hard. Okay, shall we talk about some class content? Any questions before we start getting into the content?
Yeah, I have a question.
Yeah.
Do you want our homeworks typed up in LaTeX, or can we just scan them? Or
LaTeX is great. It eventually has to get into a PDF. So yeah, LaTeX is wonderful. If your handwriting is reasonable enough and can be read, it's okay if you create a PDF. There's these things like Adobe Scan is a wonderful app that can scan paper things and produce a decent PDF. But just make sure your handwriting is legible for the grader if you choose not to use some kind of other typography. Oh yes, Mark, you're asking if I'm going to post the notes on Canvas. Yes, this document that you're seeing me write on my iPad, this notability, I will, after each one of our lectures, I will put the cumulative set of notes so far, and I think I'll just break them up into batches because the PDFs get large when you use Notability, but they will be posted on the syllabus and on Canvas. So yeah, you will get access to them, definitely. Good questions. Other questions before we start? Okay. Oh, Megan, great. You set up a Discord server. Super. So let me, before this chat goes away, and just in case I lose this, Megan, will you also send me that link in an email? I'm not going to worry about getting this off the chat now, but will you send it to me in an email?
Yeah, I can do that.
Great. Thank you, Megan.
Yep.
Okay. So let's begin, and I'll talk a little bit about the content for the class. And I have to figure out, because my desk setup is different from when I was teaching last spring. So I'm also going to shut a door. Okay, so this class uses this book. You probably have figured this out, Discrete Math by Lovas, Pelikan, and Vestergambi. You can get a PDF version that I linked from the syllabus that's free, but I don't think the homework exercises are numbered the same way. I don't think you can quite trust it. If you're having trouble getting a copy of the book, let me know. There are ways. And basically, we're going to do a lot of this book, except my style for explaining things is very different from their style. These three, they're three Hungarians, and they have this wonderful kind of chatty, cute way of explaining things. And I will focus less on the chatty, cute way and try to say a little more kind of like the mathematical ways of explaining these things. I am also, in a certain way, informal the way that they are, but you'll see that my informality is less than theirs. I just tend to focus a lot on trying to do things by examples, if I can, so that I have to make less formal definitions. All right. Hopefully the difference in philosophy will just mean that you kind of see two ways of thinking about it. And so the content in this class is, it's about less than half of it is enumeration, which is just counting techniques. That's what enumerative combinatorics is about. And the examples of how you use this are things like computing probabilities. Should be lowering the volume on my notifications. There we go. Computing probabilities. And another big place where enumeration techniques come into play are in computer science. When you want to analyze the runtime of algorithms, you need to know how many steps the algorithms are going to take. So analyzing runtime of algorithms. Okay. And then I would say actually greater than half of this class ends up being graph theory. And graph here doesn't mean like graph of a function, like from calculus. Graphs are like networks. These are things where you have nodes and vertices and things connecting them, things that look like this, So we'll talk a lot about those objects. And, the material in this class, it overlaps. Sorry, that was me flipping a page. Maybe I'll warn you next time. Any questions before I flip the page? Okay. So the material in this class, overlaps with some of the other ones in our curriculum. And let me just point out a few of them, in case you want to escape now, right? So Math 4705 is purely enumeration. Oops, I'm a little excited there. Enumeration. So that's called enumerative combinatorics. If you really like enumeration, you should just take that class instead. It's also going to be at a slightly higher level. It's going to focus more on enumeration. It's going to get into more depth, maybe have slightly higher expectations in terms of proofability and so on. 5707 is just graph theory. The thing that I said is a little greater than half of this class, okay? And again, higher expectations because of the higher number, you know, it's like nearly a graduate class, and just more depth in terms of graphs and networks. There's one called Math 5711. This is also industrial and systems engineering. I believe it's 5.3 something something. I'm forgetting the number, but I can tell you. And it's called combinatorial optimization. And there are a lot of algorithms that use networks and so on, and graphs that, you know, computers run. We'll talk about a few of those, but this class just, you know, does a lot more of that combinatorial optimization, and again, has some higher expectations. And this class, I don't want to deceive you, we're going to be skipping the chapters 6 and 15 that would have done what Math 5248 and Math 5251. So this is, we'll skip this material. This is about cryptography and number theory. Cryptology. Ooh, that doesn't look good. Cryptology and coding theory, I guess, is what 5251. And when it comes up in our book, it's chapters 6 and 15, and we definitely won't do it. Okay. All right. So any questions about, you know, like course material and you know, sort of roughly speaking what we're headed toward before we start talking about chapter 1 of our book, which is called Let's Count. You know, it's just definitely enumeration. All right, let's count then. Is this gonna work? Yes, it worked. Ooh, watch this. Let's have some fun. Let's make it green. There we go. Okay. Chapter 1, let's count. So this is, ooh, got a little messy. Enumeration. And so instead of telling you these like fun stories the way they do in our book, which are totally charming, and oh yeah, one more thing about the book. It's not only totally charming, they have these little problems, these little exercises that are numbered as they're telling you the cute stories and so on, you know, to teach you the material. Yes, please do think about those problems that they have numbered. They're sort of like the lower numbered things in each chapter. They're not our homework problems. Our homeworks always come at the end of the chapter. But those problems, as they do them, they want you to think about it, and then they've got solutions for those, or at least hints for solutions at the back of the book. So you're going to get more out of the course if you really read them along. They, as I said, they write in a charming way. Think about those things. You know, put the book down and just think about it before you go and look what they had to say about solutions. I think that's going to be a much more effective way to learn than any other, at least, you know, for part of it. Okay. But what I want to do is start in this chapter 1 with just saying some basic counting principles, which they eventually get to most of these, I think all of these, but I think I want to kind of explain them in a certain order and formalize them a little bit, okay? First one, this is your favorite principle if it can be used. You just sort of have to try and figure out, how can I get to the situation where I can use this one? It's called product principle for counting. All right, so what's product principle? It says, if I'm trying to count some set A. Okay, so we're gonna be talking about sets and the cardinality of sets, and they're gonna be finite sets when we're trying to count them. If one can choose an element of a set A by a sequential procedure, of a set A, by making sequential choices. Then it's going to be like R steps in the sequence. R sequential choices. I'll be doing an example, so I know this is a lot of words. All right, at the first step, you've got D1 choices for the first step. All right, and then after you've made that choice, you always have D2 choices at the second step. And then you keep going like this. D3 choices at the third step, D4 at the fourth. And then after R steps, you've got in that last stage or that last step, you've got DR choices for the Rth stage. Then I can tell you how many things there are in your set. The size of that set, and I'm going to use, sorry, an absolute value symbol, but sometimes I might use a number sign. Those both mean size of A, cardinality of A, is just going to be D1 times D2 times DR. And so let's say this is, you know, important enough that maybe we want to make that red or something. In other words, my set has size equal to a product, and it's the product of how many choices that I had at each stage when I'm trying to pick which element of the set I'm doing. We need an example. Before you ask a question, example. Is it okay if I flip the page here to start doing an example? Anybody have a question before I do that? Okay, so let's start with basic example. I think the book also does this one as one of its first examples. How many subsets of an n-element set are there? Okay, basic counting problem. And before you tell me the answer, I'll bet you some of you know the answer. You probably have encountered this in other places because it comes up. Let's just do a little bit of experimentation, because when somebody asks you, one of these kind of counting questions where the answer depends upon n. Oh, Theo, good guess, n factorial. That's the answer to another question. It's going to come up later, but yeah, hold on to that one. That's not the answer for this one. So let's first do some experimentation to get a sense. Yeah, Rory, 2 to the n is right. But let's do some experimentation, and just also to understand what it is that we're asking. You want to do a few small experiments when somebody asks you one of these counting problems, just to make sure, a sanity check that you're doing the right problem. So I'm going to do a little table here with n. We're just going to list the subsets of some n-element set. My favorite n-element set is just, let's take the first n positive numbers. So 1, 2, up through n. And then let's put the answer, this thing that we're looking for. Right, so that's this, how many subsets is this thing that that's the thing that we, oh, got a little crazy there. That's what I want to get at, is this, boy. It's been a little while since I've been doing my notability. I need some notability practice here. Style, do that in red, yes. Oh, and I missed some of We'll get better as the semester wears on. All right, how many subsets are there for a 0-element set? Aha, bet you didn't think I was gonna start with 0, did you? But what the heck, if it's a 0, that's supposed to be a 0. There's only one subset of a 0-element set. A 0-element set doesn't have any elements, but it does have a subset, namely the empty set. Okay, so that's the other thing, is conventions. You should always check with a person what their conventions are for things that it's not completely obvious how they would even make sense, like the boundary cases. That's my convention, is that an empty set has actually one subset, namely the empty subset. Okay. So that's, the answer there is 1. in that case. All right, let me put in a couple extra lines here. A little more interesting. Subsets of the numbers 1 through 1. Okay, so when I have a one element set, we know the empty set is there, but then the full set itself. So I'm going to put the set braces around it is also there. Okay. By the way, we're also learning just some of my standard terminologies. I'm missing questions in the chat. No, I'm not. Or am I? No, we already got this. Good. So there's only 2 of those. And maybe we're finally getting to a case where it's a little more interesting. If I've got the sets, my 2 element set is 1, 2 with set braces around it. There's the empty set. There's the singleton set 1. When I say singleton, that means a 1 element set. There's the singleton set 2, and then there's the set 1, 2. Okay. So total, there are 4 of those. And now you see where we're headed. Empty, 1, 2, 3. I'm going to go fast now. Sorry, because I just don't want to be boring you too much. 1, 2, 1, 3, 2, 3, and 1, 2, 3. Right, those are my subsets of the numbers 1, 2, 3. And you can count them. There are a total of 8 of them. Okay. And if you kept at this, you do 4 and you'll see that it's 16. And you'll see that the thing that Rory was saying, guess, 2 to the n. Does everybody recognize these things as being powers of 2, right? This thing that is a power of 2. It's 2 to the 0. It's 2 to the n, 2 to the first, 2 squared, 2 cubed, and 2 to the 4th. Okay? So do this kind of experimentation process when you're, given new counting problems that you haven't encountered before. Okay. And so how is this an example of that product principle? Let me remind you what the product principle said. How are we going to get this 2 to the n? So it was saying that if we want to choose an element of our set A, okay, so this is tricky. A here is the subsets of 1 through n. It's not that A is the numbers 1 through n. No. Capital A here is subsets of 1 through n, this thing that we think has size 2 to the n. And the point is, I can choose a subset of the numbers 1 through n in a sequential way where there are n steps. And R here is going to be n, in which I think about, first, is the number 1 in my subset? Yes or no? It might be, it might not be. I don't, it could be either way. So then I make that decision, a yes or no choice. And then in the second stage, I ask, is the number 2 in my subset? And no matter how I answered the first question about the number 1, there are 2 choices for whether 2 could be in my set, yes or no. Then I ask about the number 3 in the third stage. Is it there? The number 4. And then it stops at the nth stage when I ask, is the number n in my subset? And I answer yes or no. So at each stage, you imagine this process. So we're going to think about pick the subset S. So it's a subset of, there's a symbol I'll use. Subset of could be equal, right? When I write it with this extra line down there, I'm just trying to emphasize that S could be equal to the full set 1 through n. Could be empty, could be the full set. And you can pick it in n stages. At the first stage, I'm just writing what I was saying. Ask, is 1 in S? Yes or no? And so the possibilities are D1 is 2. It's that yes or no is the possibilities. Oops. Getting too close here to where I'm writing. Okay. And at the second stage, ask is 2 in S. And again, D2 is 2 possibilities. And at the nth stage, ask whether, oh, that was supposed to say ask. Ask is N in S. Dn is also 2. And so the size of this set A, right? A here is, ooh, another notation I'll use a lot. Not only is A equal to, I'm telling you what the definition of is for A. When I write colon equals, that means definition. Everybody okay with that convention? For definition, colon equals, I'm defining the set A, and it's all subsets of S of 1 through N. We're figuring out the cardinality of A, so that's this absolute value symbol or number symbol. And I'm saying it's D1 times D2 times ... Dn, the number of choices that I had at each stage when I want to pick an element of A. And it's 2 times 2 times 2 times 2 times 2 is 2 to the n. Right, so that 2 to the n there was definitely correct. Okay. Is everybody good with our first example of this product principle? We'll do some more interesting ones. This one was really easy, and there are many ways to think about it, but I just want to get straight what did I mean by this D1, D2, and Y product, and so on. Any questions before I keep going with more examples? Better yet, we are now at almost 3:10. This would be a totally good time for me to turn off the recording and take our 10-minute break. So any questions before I turn the recording off and we break for 10 minutes, and then we'll resume for another 40 after that? Questions? Anything that's come up? Okay, I am turning this